Alrighty, it's 9 o'clock. I hope you guys are ready, because I'm not. So, one of us needs to be. I just went to the restroom and I couldn't even get out of the restroom. That's how nervous I am. I couldn't find the door. But I think it should be fine. Hopefully, kind of. So, welcome. I want to say welcome to PyCon US, but it's also my first time here, so I feel like I should be welcomed too. But so welcome us to PyCon US. It's 9 o'clock in the morning, so it's pretty early by developer standards, if I understand correctly. So thank you for being here on time. And over the course of the next 3 hours, we're going to be taking a look at Pandas and matplotlib and some of the cool things you can do with those two libraries. I'm assuming that at this point, you've got Pandas and matplotlib installed. This QR code will take you to a GitHub repository that's going to be synced every minute. Actually, yeah, so I'm already telling lies, so I need to start the sync up. So what I'll do is I'll run the leading underscore sync.py file. You don't need to worry about that file. And every 60 seconds, it's going to pull my notebook and it's going to sync the changes so that if you fall behind at some point, you can always go and grab a snapshot of the code I'm writing. So that's the point of the leading sync.py. So that's the QR code to that repo. You can also type out the URL, but it's, to be fair, it's much easier if you just go github.com/mathspp and then instead of typing the whole repo name, just browse the repositories because it's easy to find this one. Just for some reason I swapped the day with the month. This is not the US format, right? The US format has the year in the end. It's like, it's weird. I don't know, I messed up the format, the date format for some reason. So, does anyone have any questions before we start? Okay, brilliant. So the way this is going to go roughly is, we're going to be going over some Pandas concepts, some of the introductory concepts, for roughly 90 minutes. Then there's going to be a break, a coffee break. We can head outside, stretch our legs, we can have some coffee. Hopefully there's going to be snacks, and then we'll be back for another 90 minutes of torture and some matplotlib plotting. This is rough, depending on how you react to things, to concepts, to explanations, depending on how many questions you might have. The Pandas section might stretch a bit, and the matplotlib section might shorten a bit. I hope that's okay with everyone. And then I sent you a message over PyCon US, so the point here will be, this is going to be live coded. It's going to be fairly fast paced. I'll be typing things, and I expect you, or I wish you would be able to type along, and when I stop to explain things, when I stop to make hand gestures, you get some extra time to type things and make sure that everything I'm talking about actually runs and makes sense. And throughout the explanations, I'll have small challenges, so small times in which I'll stop and I'll say, can you please do such and such? And then you're supposed to do a very small challenge that checks that you understood what just happened. So instead of going, I don't know, for 45 minutes and then stopping and then you work on exercises for 45 minutes, this is going to be very interactive. I'll stop for 60 seconds to give you time to run a line of code that just does something similar to what we just did. So the idea will be not that you see all of Pandas. Pandas is huge. I don't know all of Pandas, I can teach you what I don't know, and even if I could, you wouldn't be able to pick it up in 3 hours, it's just impossible. So the idea is that we go over some key concepts, that we go over some key methods that Pandas has, and then you just get a basis for the things that you should look up afterwards. Because when I don't know about you, when I'm starting something that I don't know, I know so little that I don't even know what to look up, right? I think this makes sense to most of us. So the idea here is that you get an idea of the things you should care about so that you can Google them later. So that's the premise for the tutorial. Is everyone ready? Does everyone have a notebook open, and you're ready to start to work? Okay, excellent. So what you will need is a CSV file that's in the repo that's called Pokémon.csv. So you do need that file, because that's going to hold, this is the file with the data that we will be using. So you do need You don't really need to clone the repo, but you need to download this file at least. And then you'll want to open a notebook close to the file, in the sense that you know how to get to the file. Also, I forgot to tell you, hopefully it's self-evident, but feel free to call me out. I didn't even introduce myself. My name's Rodrigo. So feel free to call my name if you have any questions. If I say something that sounds wrong, if I say something that doesn't make sense, just raise your hand, shout my name. If you can't say Rodrigo, that's fine. Just don't insult me. If you call me something else, I'll understand that you're trying to talk to me and ask questions. Because the point is that you leave this tutorial knowing a bit more than what you knew when you came inside. And I've written notes and I've studied these things, so hopefully I kind of know what I'm talking about. So it's not about me just saying things, it's about you understanding what I'm saying. So if you don't understand, it's my fault. So if you don't understand, let me know. Alright, so let's see if this runs. If you can import pandas, then you're good to go. Why doesn't it? This is looking bad for me. Oh, okay, so I can import pandas. Now what I'll do is actually I'll import pandas as PD, because for some reason data science in Python always imports pandas as PD, and we don't want to go against the conventions for this. Otherwise all of the data scientists in the world will come after us. So make sure that this runs. If you get an import error, then you have an installation issue. Does anyone have an import error? Does this work for everyone? This is the hardest part. So if everyone got past this, then the tutorial is going to go very nicely. So, excellent. Pandas, what's Pandas? Pandas is a Python module that you typically use to work with data, right? So if Pandas is used to work with data, we need some data. That's the Pokemon.csv file that you downloaded. And what we'll do is we will use a method called read_csv to do what? To read our CSV file. So what we'll do is we'll type the file name here. And then we will save this in a variable called Pokemon. And if you run this, it should work without any problem. Yeah? Throughout the tutorial, I'll be asking small questions, small questions. They're not rhetorical questions, okay? So if I ask you something, even if it sounds silly, I do expect a response, because I need to know if we're on the same page. So a head nod goes a long way, especially because there's plenty of you. So everyone's doing a small head nod, I'll see that we're on the same page. Okay, brilliant. So now we took our file and we've loaded it into Pandas. But let's take a look at our file. I'm not sure if everyone is familiar with the CSV format, but it's just a text file with a bunch of things written separated by commas. Yeah? I am. So I was asked for the QR code for the repo. This is the QR code for the repo. If you have to type it out, I suggest you go github.com/mathspp, look up the repositories, and the tutorial pandas matplotlib is the one you want. If it's too small, you can just get up and... Is it working now? Okay, excellent. No worries. So this should have a CSV file with 898 rows with Pokemon data. Now, who's familiar with Pokemon? Okay, brilliant. Who's not so familiar with Pokemon? Okay, excellent. That's kind of the point. So, on the one hand, it's fun because if you know what Pokemon is, I think this gives a nice flavor to this tutorial. On the other hand, if you don't know what Pokemon is, then it's going to mimic the fact that sometimes you're working with data that you don't really understand yet. And so the idea is that there's this game, TV series, cards franchise called Pokemon. No, not that one. I want to Google Pokemon. And there are these... No, not this one. Sorry. Typing is hard. And there are these funny-looking creatures. And I think the most famous one may be a yellow one that I want to show you if Google works. Yes, so do you know, for the folks that are unfamiliar, okay, so the internet is really bad, I can see that now. Do you know this yellow character here? The people that don't know Pokemon, have you seen this yellow character? this is a Pokemon. There are these different creatures, they have different looks. For example, this one here, it's a different Pokemon, this one as well. There's just creatures, and they have names, and they have different physical attributes, and then there's this guy who wants to capture all of them. It's fun. Inside I'm just a kid, I'm sorry. And so this is the data we'll be working with. For example, you can see here there's a bunch of different words. These are Pokemon names. And the data contains all of this information. So this is the file itself. But we've somehow loaded the file into our notebook. And now the first thing you do whenever you load a file into Pandas is you do Pokemon.head. So you've read the file into the variable Pokemon, and so what you'll do is run Pokemon.head, and when you press enter, you're going to get something that looks a bit like this. And this head method is going to let you pick at the first few rows of your data. So this is going to give you a feel for what you're holding, for what your data is. And we can see at the top we have column names that should be describing the information that goes in the column, and then each row is going to represent a different Pokemon. So for example, at the very first row we have this national number thing, that's a 1. This gen, which stands for generation, this is a 1, a Roman numeral 1. And then the Bulbasaur is the name, the I don't know how to say this, Fushigidani, I don't know, that's the Japanese name. And then the grass and the poison, these are things about the Pokemon. And then this classification, the seed Pokemon. And then you've got numbers. And then you've got an ellipsis, because the table is very large, so it doesn't show you the whole thing. And then you've got the final columns here, these Evo chain thingies, and then at the end, this description, which is just some text. Now, if you run Pokemon.head, can you see something like this? Excellent. So this is the very first thing you should do whenever you load some data into Pandas. But now the thing is, what is it that Pokemon really is? So this is a variable. It's the result of pd.read CSV, sorry. But what is this? Well, doesn't look like a string. Is it a list of things? Is it a list of lists? Is it a tuple? Is it a dictionary? So the thing that you're holding in your variable Pokemon has a very specific name, and you might have heard this. So this thing is called a data frame. If you run type Pokemon, the output ends with data frame. Now, what's that extra string there? Yeah. So the data frame is the fundamental data type in Python when you're doing data science, and I think even in other programming languages we have this concept of data frame. You can think of it as a table, and it's a table that holds your data in this specific format, which is each row is going to represent a data point or an instance of a piece of data that's interesting. And then that's a nice ringtone. And then each column is going to represent a variable of that thing. So in our case, each row represents a Pokemon, and each column represents something, some piece of information about that Pokemon. It can be the national number, it can be the generation, it can be its name, etc., etc. Making sense so far? Okay. Sadly, I've tried really hard. I haven't found a way to turn this beginning of the tutorial more interesting. I just have to tell you a couple of things, and then we can start writing more interesting pieces of Pandas code. So this is the data frame. Now the data frame is composed of these columns, and you can access these columns. If you go over your Pokemon variable, you can type something like, I don't know, inside square brackets, you can open the parentheses, and you can say something like, let's see, English name. So if you type the name of one of your columns and you press enter, then you can take a look at a single column. And you see that the single column, when I try to print it, it's going to show me a couple of Pokemon names, starting with Bulbasaur, then it's going to end at Calyrex, and then it has 3 extra pieces of information at the bottom. This name thing, this length thing, and this D-type thing. Can everyone see this column when you type it, or some other column? Now there's one interesting thing, I don't know if you've noticed, but there's both when you type Pokemon.head and when you've typed Pokemon and then a column name, there's a bunch of numbers on the left. 0, 1, 2, 3, 4, up to 897. Now these numbers, these aren't in your data. It's not like the column has a 0 and a Bulbasaur. The values of the column are the names. They're the words on the right. The numbers on the left, they're called indices, and you can kind of think about them as an index into a regular list, as in if I were to type a square bracket here and a 0, I would be able to get a Bulbasaur. Or if I were to do, I don't know, square brackets and then 8, 9, 7, you would be able to get the last name. But the point of these indices is not really that you use them as you would with indices in a list, because the point of these indices is just to let you figure out which row is which, even if you slice up your table, even if you reshuffle the rows, because the point is that the indices will, when you keep learning about pandas, the indices will be used to be able to tell different rows apart. And for more advanced operations, you will need these indices so that you know what data goes with which data. And so the whole reason I'm saying things that don't make sense is that, on the one hand, we acknowledge that these things are here, and on the other hand, we acknowledge that sadly, we won't pay a lot of attention to these indices during this specific tutorial. I just wanted to let you know that this is not in the data. It's not the column. It's just an extra piece of information that Pandas uses. So good so far? So far so good, sorry? Yeah? Any questions? Okay, brilliant. So when we did Pokémon.head, there was an ellipsis here in the middle because where is it? There's just way too many columns. So what we can do now is we can do Pokemon.columns, and then the data frame will tell us all of the columns that we have. So there's going to be a huge list of names. And now, if you know Pokemon, some of these will make sense. If you don't know Pokemon, then these won't make sense, but it's fine. There's plenty of data here. What we want to do now is grab a portion of these columns to use throughout our tutorial. So there's things that are superfluous. So how do we get rid of those? When we did Pokemon what was it, English name, we grabbed a single column, right? Now what we want is we want to grab multiple columns. So what we can do is we can define a list with column names, and then we can use that list to fetch only the columns that we care about. For example, if I put here the English name and the Japanese name, so this is a list with 2 entries, and if I do Pokemon and then square brackets columns, then I get a data frame with only these 2 columns. So make sure that this works for you, please. Okay, brilliant. Now, can you please let me know what happens if instead of 2 names, you only have a single name in this list of columns? Can you give it a go and let me know? Feel free to shout what you find. Okay, so it gives me a list of just the one. Sorry? I'm just literally repeating for the purposes of the recording. So what should be happening now is I should be getting a data frame with only 1 column. And notice how when I type this, so there's a single name inside my list of columns. I index with a list of columns. It's just one column, but it's still a list with 1 value. And when I index into it, what I get is this thing here that shows me it's 898 rows by 1 column. And so this is a data frame, which is different from doing just Pokemon English name with a single string, which is a something. It's a column. Do we agree that the outputs look different? Excellent, because if we can't agree on that, then I can't help you. Now let's see what this actually is. So if I go ahead and if I copy this and I paste it inside type, we can see that this is called a series. So data frames have series. Each column, when I talk about the column, usually I'm talking about a series, which is something that you can think of as being kind of like a list, but it's a quote-unquote list with lots of very useful and powerful methods that Pandas gives you to be able to work with your data. Can everyone check that you get a series if you check the type of a single column? Okay, brilliant. Now, series have 3 extra pieces of information. Series know their own names, that's what's being shown at the bottom. Series know their own length, or they show it to you when you print a series, and then series also have this D-type thingy. Can anyone venture a guess on what D-type stands for? Yeah, so D-type stands for data type. I think I'll ask plenty of these small questions. People will just say things and I'll repeat them. If you, there's no way you're gonna be able to hand the mic. Okay, so D-type stands for data type. So each series in Pandas is supposed to hold, or it expects to hold, values of a single specific data type. So it's, for example, if we go back to our whole data frame, this English name column, this series is going to be holding strings. And it kind of makes sense that the column only holds strings. If you look at the national number, for example, this one is holding integers. And so if you have columns that hold a specific type of data, then Pandas is able to optimize the way it stores the information and the way you work with information. So it's going to set a specific data type for that series, and then you can access the data type to check what's in there. And when you load the data, when I loaded the data with read CSV, and when you loaded the data, I prefer the other ringtone. This is less interesting. Don't you agree? This is much more standard. Okay. So then when you read the CSV, Pandas will do its best to figure out the data type of each column. Sometimes it will get it right, sometimes it will get it wrong, and when it gets it wrong, then we can change it. Because again, there's benefits, especially memory and speed benefits in getting the data type of each column right. Bless you. Alrighty, so then if we have a bunch of columns, how can we check the data types of all of our columns? You can do something like Pokemon.dtypes. So when you do that, how many different data types can you see in front of you? I cannot believe that no one here knows how to count up to 3. How many different? So on the left we have the column names, and on the right we have the different D types, the data types. How many different values can you see? Just quickly. 3. Yeah, I mean, if you scream 2 or 4, it will be fine. I just want you to be awake. So the object one is kind of a fallback. If Pandas can't figure out a better, more specific data type, it's just going to go with object. It's the generic one. int64. Does it look like a Python built-in type, this int64 thing? No, does it? Okay, so not as in, is it exactly the same, but doesn't it look familiar? Okay, to which one? Yeah, exactly. So the int64 is going to be for integers. It's not the same as the Python int, but it's similar. And the float64, what does it look similar to? To floats, exactly. So it's going to be for floating point numbers. Do you care what the 64 is for, or can we skip over that? Who cares about the 64? Okay, so it's about the Jim at the back cared about the 64. Excellent. Thank you, Jim. So the 64, do you know that Python handles arbitrarily big integers? Were you aware of that? You can have arbitrarily large integers in Python. For example, let's see if I can blow up my REPL. Let's do 2 to the power of 100. That's nothing. Let's do 2 to the power of 1,000, 10,000, 1,000,000. No, okay, so it's not that the integer is too large, it just can't convert it to a string. Good. So if I do something like 2x, 2 to the power of 100,000, exactly. So the value is there. It's too large to convert into a string, but the value is there. Okay. So Python handles arbitrarily large integers, but Pandas, when it can, it will say that these integers have a fixed maximum size, because if there's a maximum size for your integers or a maximum precision for your floats, then you can do some operations faster. And so Pandas by default will use integer types and float types with a specified limited precision or size. Does this make sense? Okay, brilliant. So then there's 3 values here, and what we will see is that for some of these columns, the data types are not really correct. So what we will do later on is, for example, can you see these 3 is something columns? The prefix is really hints at the fact that these are Boolean columns, but Pandas was not able to pick that up, so we will fix that later on. Or for example, this, where is it? This primary type column, we really don't want it to be an object, we want it to be something more specific, so we will work on that. Now this is, I don't know, 55 columns I think. Actually, can you guys figure out, please, how many columns are there? Can you do something and tell me how many columns we have? Okay, so 2 different people told me already that there's 55 columns. For example, if you do .head, it's going to say 55 columns. If I do the length of Pokemon.columns, it should give me a 55. Yeah, so there's 55 columns. Let's get rid of most of them. For the remainder of the tutorial, the columns we care about are the English name. Again, I'll give you a second to type this out after I type it. So let's go with, let's see, which ones do I like? I like the English name, I like the HP, I like the attack, the defense, the SP underscore attack, SP underscore defense, speed, I like the primary type, I like the 3 is something columns. So this is a lot to type, I'll make sure that I sync this to the repo. Or if you're feeling brave, you can just type it out with me. Is mythical, and I think this is enough. Let me check my notes. The type, HP, attack, defense, special defense, speed. Yeah, this is enough. So feel free to jot this down, and then how was it that I was able to fetch only these columns from a data frame? Try to do that. Try to type these names out and index into the data frame to get a smaller data frame that has as many rows as the original, but only a subset of the columns. From your point of view, will this work? I can't see if the microphone is in the way. Give me a nod when you've managed to index into the data frame. It works? Excellent. Alrighty, so 30 more seconds and then I'll do it myself. By the way, if you didn't want to type this, remember that there's the repo and the changes should be syncing. So you should be able to just go there and grab the latest version of the notebook with these things typed out. Yeah, so in the repo it's already there. Alrighty, so if you have a list of columns, again, what you do is you can type the name of your variable holding the data frame and use square brackets to index into the columns. Now the thing is, if I check Pokemon.head again after indexing, I still have the 55 columns, right? Because I only indexed into the data frame. I didn't change my data frame in place. And what we will start doing now is learn about other methods to not change your data frame in place, but to create new data frames with new results, with new columns, with new values. And the fact that we won't change things in place, the fact that we will be creating copies with the new results, is going to be very interesting. It's going to produce a very interesting result in the end. So then, if you want to grab only this subset of columns, what you need is you need to update your variable, and then if you do Pokemon head, you see that now you have a smaller data frame. So go ahead and make sure that you've reassigned Pokemon so that we have a smaller subset of the columns. and check that through Pokemon Head. Is it working? It was 5 by 55 in the beginning. After indexing with a shorter list of column names, it should be much smaller. So notice how this is. So why is it not? Let's see if I do this, what happens. Yeah, if you just type Pokemon, after reassigning, it should be 898 by 11, because the columns list has 11 names. So after this should be 898 by 11. Can everyone reproduce these results? So you've typed the list of names, yeah? And then you need to reassign. Notice how there's an assignment in my line of code here. And only then the data frame is smaller. Did it work? Are you on it, Julia? Yeah? Okay, brilliant. Alrighty, so then, let's start doing some interesting operations. There's a couple of columns here that I really like, because we'll be able to... I studied mathematics at university, so I like numbers. Actually, I don't love them, but for some purposes they're fun. And we have a bunch of numbers here, and so I would like to do some interesting things with them now. Pokemon, like I said, they're those funny-looking creatures, and apparently in the world of Pokemon, humans use Pokemon and battle against other humans with Pokemon. And Pokemon have these physical attributes that let you know how strong a Pokemon is. And these 6 columns here, HP, attack, defense, special attack, the SP stands for special, special defense, and speed, they're the names of these attributes that let you know how good a Pokemon is. It's the same thing as saying that I can bench press X, I can run 10 miles in however much time. English is difficult, sorry, I think I messed up the adverbs there, but yeah, you get the idea, right? It's the physical attributes of the Pokemon. And for these 6 columns, the larger the number, the better. So for example, if we look at Bulbasaur, there's a 45 here under HP, and there's a 60 over here for Ivysaur. So this second Pokemon is stronger than Bulbasaur with respect to this HP column, okay? Why? Because this 60 is larger than 45. We all agree on that, right? If you don't agree with me, you can ask Python. So let's see. Okay, excellent. So then, that's the idea. These numbers represent in some way how strong a Pokemon is. Now the thing is, in the game, you can actually see those numbers. You can open a page with details on your Pokemon and you can check the numbers there so that you can compare to different Pokemon. But the number that shows there, the actual stat, that's what we call these things. So we call them stats, short for statistics. The stats, they're not these numbers. These are just, the numbers here are used in a formula to compute the actual stats. And what I would like is, I would like to compute the actual stats that you see on the games, because I don't know what these numbers mean, because if I open a game, I won't see these numbers, I'll see a different number. For example, let's look at the HP column. There's a formula that the game uses, and that's going to be 2 times the value of HP plus 110. So this is the formula that's... Is this big enough? Probably not. It's just a reference. I just want you to know what the formula is. So given the value in the column, which is the HP, what you need to do is you need to do 2 times that value plus 110. Okay? I'm just letting you know that that's the formula. So if I look at Pokemon HP, what's the first value that I get there? It's the 45. So if I apply the formula, what should be the result of applying this formula to the value of the first Pokemon? 200, exactly. So that's just going to be 2 times the first value in the series, which is the 45, and then plus 110, and it gives me 200. Right? If I apply the formula to the next Pokemon that has a 60, what should be the result? Okay, and we just keep going. Now the thing is, I want to compute this for 898 Pokemon. I'll give you, how much time do you reckon you need to be able to compute all of those? Some time, right? I mean, if you know some Python, you would probably maybe do a loop over this index here. But this is a very common thing. You have a numerical column and you want to compute a new value out of that column, and so Pandas gives you a way to compute that in a very concise and efficient manner. Notice how Pokemon HP is the whole series? Do we all agree that this is the whole series? Now what if I did 2 times this? Do we all see the 45 at the top? Now I'll rerun my cell. Do we see a 90 where there was a 45? Notice how, and there was a, what if I do this side by side? Will this work? Nope, not kind of. So we had a 45, now we have a 90. We had a 60, now we have a 120. We had an 80, now we have 160. So when you do a basic mathematical operation with a series that holds numbers, this operation will be applied to the whole series, not just to a specific value. And this thing is a very important concept in Python, in Pandas and NumPy, which is called broadcasting. So a series is a one-dimensional thing. It's kind of a list of values. And a number, it's just a number. It's a zero-dimensional thing. And when you do 2 times the whole series, the 2 will be multiplied over all of the values in the series automatically. Pandas broadcasts the 2 over the whole series. Do we see that the 2 times is being applied to the whole? So then, who can guess what I need to do to finish the formula? I just need to add 110. I need to add 110. And if I add it in at the front, it just works, because the plus is also a regular standard basic mathematical operation. So the plus 110 is going to get applied across the whole series. Does this make sense? Okay, brilliant. So now I need you to do something else for me. So this was for HP, and I said, maybe it wasn't very clear, but there's 6 stats. They're HP, I'll type them with the column names: defense, special attack, special defense, and speed. These are the 6 stats. They're written here. And the formula for HP is the one I showed you, 2 times plus 110, but for the other 6 stats, the formula is different. It's 2 times the stat plus 5. The formula is slightly different. So what I would like you to do, please, is figure out the values of the computed stats of these 5 stats: attack, defense, special attack, special defense, and speed, according to this formula, which is slightly different. Just try and figure that out and let me know, for example, what the speed is of the last Pokemon. So the one at the bottom, what the speed value is. I'll give you 60 seconds for that. Sorry? 165. Can anyone confirm this value? I don't know it by heart. So I've got some confirmations. 165 is the final speed of the last Pokemon? Okay, excellent. I'm glad you all agree. Now let's see if I agree with you. I probably do. So if I do 2 times the speed plus 5, I get 165. Excellent. Okay. Now the thing is, I started by asking that, but then I really didn't. But what I really wanted was the final values of these 5 stats, because the formula is the same for all of these 5. And maybe you thought of writing down the formula 5 times, and that would be fair, but actually we can do even better. What we can do is, we can create a list. Remember that if you have a list of column names, you can access those columns. So what I'll do here is, I'll list all of the 6 stats. The attack, the HP, the attack, the defense, the special attack, the special defense, and the speed. I'll list them. And just to make sure that I got this right, let me try and index into my data frame. Yes, so let's create a list with the 6 stats and just make sure that it works, that you can index into the list, into the data frame with that list. So it's going to be HP, attack, defense, SP underscore attack, SP underscore defense, and speed. Now, is indexing working all right? Okay, excellent. So now, what we'll do is, which ones had the same formula, the plus 5? Yeah, the last 5, exactly. So not the HP, right? So what I'll do is, actually I'll leave this list alone, because this list is useful, and it's going to be useful later on. So what I'll do is, instead of indexing into the whole list, I'll skip the first one, because that's HP. So now I have a data frame with 5 columns, and I want to apply the same mathematical formula to all of these columns. How can I do this? If you were to guess, and remember that we just talked about broadcasting, so maybe trying broadcasting would be a good idea. How can I apply a 2 times and then plus 5 formula to this whole thing? What if I just typed 2 times plus 5? Does it work for you as well? It should. So broadcasting, it doesn't work only with series, it also works with data frames. So you have 2 integers and the whole data frame. So when you do 2 times and then the plus 5, those 2 operations will be applied to the whole data frame. And that's why in this case we only pick the stats that we care about, so that we multiply by 2 and then add 5. Does this concept of broadcasting make sense? Because whenever you get the chance, and you will have many more chances than at first you might think, whenever you get the chance, broadcasting is far superior than you. Have I told you that English is hard? Broadcasting is far superior to looping, or to, I don't even know the name. It's like a forbidden method in Pandas, something that you should avoid at all costs. And I avoid it so much I don't know the name. But something that's slightly better than a loop, but also way worse than loops. Because broadcasting really is fast. NumPy is built English words. NumPy is optimized, I'm sorry, it's very early. NumPy is optimized for broadcasting, and Pandas is built on top of NumPy, if I'm not mistaken. Did I say something silly now? I think it is, right? Yeah. So then, broadcasting really is useful, helpful, and typically much faster. If I do something like, let's see, remember how was it that I did? I computed the HP just for the first Pokémon by doing HP and then indexing with a 0. And then adding 110. And let's see what happens if I use broadcasting to compute the whole thing on the whole series. That's not. I was hoping this was even faster than computing just one. But if you do a loop here for row in range 898, that's how many rows there are. And if you compute the final HP for each row, that's going to take almost 10 milliseconds, and the broadcasting version takes roughly 1 millisecond. So you can see that broadcasting is much faster And for more complex operations, the advantage is even bigger. Okay? Just to make a point. So broadcasting, whenever you can, use it. Okay, but this is a very simple, the two cases of broadcasting we've seen, they're very simple. It's just integers and a series or a data frame. So now let's take it up a notch. Because what I did was I created a list with the 6 stats, and they have 2 different formulas. They're very similar, but they're different. It's always 2 times and then plus a number. Now what I'll do is I'll write down a tuple with a plus that I need to add for each stat. So for HP, it's plus 110, right? And then for the other 5, it's plus 5. 1, 2, 3, 4, 5. Do we agree that this is it's maybe too close to the bottom. Is this visible? Kind of. Okay. I can do something slightly better. No, I can't. Can I? It's not much better, but sure. Okay. Actually, I prefer it this way because then it's further in. Okay. So now I have a 110 for the HP, 5 for the attack, etc., etc. Now what I'll do is I'll try to use broadcasting to compute the final values of the 6 stats all at once. Because if I do, so let's leave this here, if I do a 2 times Pokemon stats, obviously this works because we've already seen it works. But now there's the HP in there, and I want to add 110 to the HP, while I only want to add 5 to the other stats. But the truth is, if I copy this tuple here, and if I do a plus this, and if I run it, this will also work just fine. Now what I want you to do is just run it and make sure that it works just fine, and then I'll go over it. If it doesn't work, feel free to scream. Or raise your hands if you're shy. Okay, so it's working for everyone. Excellent. So this is a slightly more advanced use case of broadcasting, because now we have things here, and all of these three things have 3 different dimensions. The data frame here in the middle, it's kind of like a table, so it's 2-dimensional because it has rows and columns, right? It's 2D. The integer is just a number, so it's 0-dimensional. It has no dimension. When I say that an integer has no dimensions, is this something that you understand? Right, okay. If I say that a piece of paper has 2 dimensions, is that something we understand? Okay, so then if I tear a a ridiculously thin slice of the piece of paper, the thing that dangles off my fingers, do we agree that that has a single dimension, that very thin strip of paper? What if I say that... Okay, so the screen is 2-dimensional. A single row of pixels, that's 1-dimensional, because you can only go left and right. On a screen you can go left, right, up, down. On a single row of pixels you can go left, right, so it's 1-dimensional. On a single pixel you can't go anywhere. It's 0-dimensional. So you have a table, 2 dimensions, you have a series, 1-dimensional, and you have an integer, 0-dimensional. You can't go anywhere. Or a table, if you slice a table, you get a column. So you had 2D, now you have 1D. If you have a series, and if you slice it, you get just a number, 0D. Okay, so an integer, 0 dimensions, a table, a data frame, 2 dimensions, and our tuple here, 1 dimension, because you can go over it, you can iterate over it. And what Pandas does is, well, first the 2 times, that's very easy to guess what happens, and then when Pandas does the plus and then the tuple, Pandas will realize that this has 6 values, and the data frame on the left, this whole thing, has 6 columns, and so what it will do is it will add each number to each series. in turn. So the plus 110 is going to get applied on the first series, and the plus 5s to all of the other series. Is this does this feel sensible? Okay, so then what if I told you that the special attack wasn't a plus 5 but a plus 200, what would be the special attack of the third Pokemon? I don't know, maybe, let's see. So to change the plus on the special attack, you go to this value. Why is it this value? Because special attack is the third. I'm sorry, I can't ignore this. Do you hear like a zipper? When I talk, I hear something that feels like the zipper of a bag. Could it be my breathing on the microphone? I'm going nuts over this. I feel like there's just someone zipping okay, so maybe it's inside my head. Okay. So the question was, what if the formula for so it is my breathing. Okay. I'm really sorry. So what if the formula for special attack is different? Instead of being 2 plus something, 2 times something plus 5, what if it was 2 times the special attack plus, what value did I say, 200? 200. So in order to check that, what I need to figure out is what of these values is being added to the special attack column, and the special attack is the third from the right, so I need to take a look at the 1, 2, 3, the third number from the right, and change it to a 200. And if I change it to a 200, then the special attack series is updated. Okay. Is everyone okay with this? Am I going too fast? Just right? Too slow? I'm not going too slow for you guys? Ah, excellent. I'm going too slow for you? That's, yes. You can, of course. Shame on you. I'm sorry. Okay, so did you hear the part where... Are you familiar with Pokémon? Okay, that in the games you have the stats and you have the numbers to compare Pokémon, and the data that we got in these HP attack defense columns, they're not really the stats inside the game, they're numbers that you can use on a formula to compute the final values. And so we're trying to compute those final values. Does this answer your question? And then, so this is, at this point, that's what's happening. At a broader scope, we're just taking a look at different Pandas concepts. And right now we're looking at broadcasting. Yeah? Okay, excellent. Okay, so we've computed these final stats. We've been on this for a couple of minutes now. Now what I want to do is I want to save this in my data frame. I've gone through so much trouble to compute this. Now I want to be able to save this into my data frame because I will need these numbers later on. So how do we do that? Now, there's a method called assign, and you can use this assign method to assign new series to a data frame. So if I do something like, let's see, HP final, and notice here, I'm not sure, I don't know your Python level, I don't know how comfortable you are with Python, but what I'm doing now is I'll be using this method and then I'll use a keyword argument. So HP final there, in the bottom, is it visible now? Okay, so it's without quotes, because it's a keyword argument to the method assign. So the HP final, I can assign it to a new series. For example, the thing that we've computed earlier, which was the 2 times HP plus 110. And if I run this now, what I get is a slightly larger data frame, because on the right, I have my HP final series. Okay? So now go ahead and try to add the attack series with the 2 times plus 5. Try to add it here. Okay, yeah, try to add it, sorry. I'll give you some seconds for that. Yeah, everything is +5 except for HP. Mm-hmm. Did you manage to get it? Ah, interesting. So the HP final went away. So what if you replace the HP with attack final, then you get the attack final on the right, but the HP went away. Precisely because the assign method, it doesn't change things in place. When I say the term in place, do you know what that is? Because it's what it says on the tin. So if I do something like so I've got my list here, and my preferred numbers for demonstrations are these 5. And I do tend to use these 5 I don't know why, but I use them. So this is my list. If I do something like my list, and then index, and then put a 999 there, then the value of my list was changed. I changed the list in place, because I had one list. It's still the same list, it just has a different value there. As in, what's the ID of my list? This is like the, let's call it the social security number of this list. So every list has a different social security number, right? And my list has this 2240 social security number. So now I'm going to change the 999. I'm checking my list, it does have a 999 there, and the social security number of the list is still the same, so it must be the same list. It's just it has a different value. So if you dye your hair a different color, you're still the same person. You just have your hair is just a different color. So you were changed in place because it's still the same object, just has a slightly different characteristic. My data frame here, when I do, did this make sense? So then, on the other hand, when I do assign, I'm not changing the data frame in place. I'm creating a new data frame, and so what you see here, this thing that's taking up almost all of the screen, it's a copy of the original one. And so as soon as I do Pokemon.assign and I run it, it's printed, and now I lost it because it was not assigned. I created a copy, I printed it, and then it's gone. And that's why if now I do in a different cell, so notice how there's that. I ran this cell, no tricks up my sleeve, I rolled my sleeves up for the whole tutorial precisely because of this. I'm just gonna get rid of this. And now if I do, instead of attack, if I do HP, here it is, Pokemon assigned, there's the HP there, and if I scroll right, the attack final is gone. Because I didn't change my data frame in place. I created a new copy. So this is very good when you're trying things out, when you're looking at your data, working with it first. If you were changing things in place all of the time, you would be screwing up very frequently, which is common, and then you would have to keep reloading the data and redoing all of the previous steps. So the fact that you're working on copies, it's actually good now. So how do I create all of these at the same time? Well, one thing you could do is, these are keyword arguments, so you can just add more. You can do attack final under this. Just don't forget the comma after the first one. I actually have the wrong formula here. So now, if I scroll right, I created 2 columns. So make sure that this works and try adding a third one, maybe the defense final. Make sure that it works and that you created 3 extra columns. Did it work alright for you? Okay, brilliant. So then, Then what? We had 6 stats. We've used broadcasting to compute all of them at the same time. And now I have to write them down one by one to create the 6 corresponding columns. Who thinks this feels reasonable? Who thinks there must be another way? Okay, because that's a good feeling. When you get the feeling that there must be another way, it's time to Google. We don't need to Google because I know where we're headed, but it's an indicator that you should probably try and figure out the best way to do this. So assign works on single columns, or a bunch of columns that you jot down one by one. Now what we'll do is we will take our 2 times Pokémon stats plus 110, 5, 5, 5, 5, 5, and we will join this with the original data frame. And when I'm talking about join, I don't know your experience with Excel or Pandas or whatever. We won't go into advanced joins. I just mean I have a big data frame, I have a new data frame, and I'll glue them together. It's very simple. And the way you do this is through the join method. So it's Pokemon.join, and then inside the join you type the expression that creates the data frame that you want to tag on the right. Now, what happens if you run this? I haven't pressed the enter yet. So if you run this, does it work or does it scream at you? Sorry? It screams. Gently, but it does. It does scream at you. So there's actually not very gently. There's a value error there. And if you scroll down, it says that the columns overlap, but no suffix was specified. And in fact, what's happening here is, or the issue is, if you take another look at the data frame with the final stats, let me just put it here, the names here, they're still, so it's not the original values, but it's the original names. And so what Pandas is complaining about is that the original Pokemon data frame has 6 columns with these names, and then you're trying to join with a different data frame with the same column names. And Pandas doesn't like that, because I don't think it's reasonable to have 2 columns with the same name. So a way to fix this is by adding this thing they talk about, this suffix, that lets you create a different name for the thing you're adding. So here, the way we fix this is by saying that the right R for right suffix is going to be something like final. So the columns on the right, so the original one goes on the left, the thing you're joining goes on the right. The columns of the right data frame, they'll have their names changed to have a suffix of underscore final, because that's what this expression computes. It computes the final values of those stats. So if you run this, if you scroll right, you'll see HP final, attack final, defense final, special attack final, special defense final, and speed final. And there's no overlap with the original names. I see some confused looks. Or is it just, it's difficult to interpret faces with masks on, especially with my social skills. So, is everything fine here? Okay. Yes. Just try it out. Okay. It's faster. So one thing I like about Python is that it's just so easy to test things out. And when I'm teaching Python to people who don't know how to program, one of the things I really focus on is tell them, just open the REPL. Instead of asking me what happens if you do X, just type X and see what happens. And then maybe ask me why it didn't work or why it works. But just try things out. Did it work with an L suffix? It didn't?
Put the suffix on the left side of the table.
Exactly. So it worked for me, as in it didn't. So I changed. There's an L suffix there.
It worked, but I didn't see the
He wanted to have not suffix but prefix, right?
I wanted to see if I put L suffix, if it would put final.
So then it might just be a confusion on what the L and the right stands for. The left, it's the left data frame. The right is the right data frame. If you want the text to go on the left of the name of the column, it's not a suffix, because the suffix is what goes at the end. If you wanted to go in the beginning, you would have to check if there's like an R prefix. There's no R prefix. Is there just a prefix? Doesn't feel like there is. Let's see Pokemon.shine. Way too much information here. L suffix, R suffix. I don't know what this auster is. Okay, so apparently there's no obvious prefix thing, but what you can do is you can write an expression here and then change, or beforehand you can compute the expression here, you can change the names here and then you join if you really wanted to add a prefix, for example. Okay, more questions about this. Okay, so then we've changed this, but again, this didn't change the data frame in place, so if you want to save this for later, what do you need to do? You would need to reassign. And we've just been reassigning a bunch of stuff, and it might look a bit boring and a bit ridiculous, but bear with me till the end. Okay, so there's one final thing I want to compute maths-wise, and then let me just check my notes and see how we're doing with time. Okay, so we need to go over this because this is a lot of fun. Okay. We're doing good. We're doing good. So there's one final thing that I want to go over when we talk about broadcasting and maths and things like this. We've seen these 6 stats, but 6 is a very big number. I mean, it's huge. And so what we often do in the Pokemon world is we boil down each Pokemon to a single number to make it even easier to get a rough estimate of whether a Pokemon is better than the other one. And what we do is we take these 6 values, the 6 base values, not the formula, not the ones after the formula, the 6 base ones in the data, and we add them all up, and then we get a single summary number that we use to compare 2 Pokemon. And then if one Pokemon has a much larger value, then it's probably a much better Pokemon than the other one. Okay? We call this the total stat because we just added everything up. So how do we go about computing this? Now there's, again, I don't know how obvious it is, but we were able to add numbers to series, we were able to multiply numbers with data frames, we were able to add data frames and tuples. So maybe it's not very surprising, you let me know, but maybe it's not very surprising that I can do something like this. I have 2 series there, they have the same length, they're from the same data frame, and so I can just add them together. Is this surprising at this point? It's fair if it is, I'm just curious. But it's not very surprising, right? So if you wanted to compute the total, what could you do? You could just type the plus other 4, right? So just type one more to make sure that it's working. If you don't mind. I'm sorry I'm giving you too much trouble, but I mean I'm in a position of power now, so I have to yeah. So does it work for you? You can add other things. Excellent. And you can even throw me off and add a +1. It's still going to work. Now, again, do you want to write down 6 factors? It's not factors in a sum, but do you want to add write down these 6? So if it feels like too much trouble, what do you need to think? There must be a better way, right? Excellent. So now there's an interesting thing. I said a couple of minutes ago that series, you can kind of think of them like lists in the sense that they're one-dimensional and they're holding a bunch of values, but they have lots of useful and powerful methods. For example, a series, a numerical series, has a mean value that lets me compute the average or the mean. What if I wanted to sum all of the values in my HP? What method would I try to use? I think I heard it. Sum. Don't be afraid, I just have a terrible hearing, so you have to really say it out loud. So I can compute the sum of all of these values. Okay? Is anyone surprised by this? No, it's very useful. Now what if I did Pokemon stats plus sum? if I do this, will it? Let's guess. Let's not gamble, but let's guess. Who thinks this is going to work in some? This is going to compute something. Who thinks this is going to error out? Okay, no one does. So now, if I run this, what will it compute? Ah, okay. So here at the front, I've got to guess the total for each column. Does anyone care to guess something else? Or do we all agree with this guess? Let's just go with this. Okay, let's see what happens. Yeah, so we get the total for each column, which is cool, it's convenient, but it's not what we want. Because what we want is we want to gather the values of a single row. So for each Pokemon, I don't want 6 final big numbers, I want 898 summary numbers. So then we go into a very interesting concept, which is the concept of an axis. So how many dimensions does a data table have? 2 dimensions. And when we did this sum, was I summing along the columns, so vertically, or horizontally along the rows? Vertically. So what if there was a way to tell Pandas, hey, don't sum in this direction, just sum in this one? Wouldn't that be useful? Excellent, because that's exactly what Pandas lets you do. So this, the vertical axis was the default, is the default behavior. What I need to tell Pandas is, instead of using this axis, use the horizontal one. And you specify it with an axis equals 1. And if you run this, now you get all of the totals for each Pokemon. Just make sure that you can run this, and then ask me questions about it. Yes. Would it not be useful to get a column with this? Yes, it would, and that's what we'll do in a second. Okay, so does it work for everyone? Okay. Do you understand the x is equals 1? Do you get the visual thing that's happening? So what happens if you do x is equals 0? I didn't mean an extra sum. I meant replace x is equals 1 with x is equals 0. Ah, every column. Okay, so then I misunderstood what you said. Okay, so x is equals 0 is the default. X is equals 1 is what we wanted. And then x is equals 2, what's going to happen? It's going to error because there's not that many x's. So then if you have a 3-dimensional thing, it would be reasonable to expect that you would be able to sum along 3 different axes. Okay, so in the room, 3 axes up, down, left, right, front, back. Okay. So far so good? Yes.
When we have axis equals 0, the first number represents the HP of all of the Pokemon.
It represents all of, yes, the HP, the sum of all of the HPs of all of the Pokemon, yes.
Okay. And then when we have it set to 1.
This represents, so if you do head, you can specify how many rows you can take a look at. So let's take a look at the very first row. See Bulbasaur here. If you do 45 plus 49 plus 49 plus 65 plus 65 plus 45, you will get exactly 318.
So it's the sum of the stats versus the sum of an individual stat.
Yes. And again, the main difference is, and just to the 405, just make sure we're on the same page, the 405 here is the 60 plus the 62, 63, 80, 80, 60. So the difference between x is 0, I'm just gonna wave at the, just no mind that the recording doesn't capture me. The difference in the axis is either we sum here, we sum vertically along the speed, vertically along the special defense, vertically along the special attack, or we sum the first row, whoa, that was scary, the second row, and dangerous, The third row, that's the difference, yeah? And again, the axis really does, it just tells you the direction in which you're summing.
That's very helpful, thank you.
What, the part where I tripped? Yeah. No, especially that part, okay. It was hidden, then later you can come up front. It's very dangerous to give a tutorial at PyCon US. Okay. Brilliant, so now, what do we need to do? We need to do exactly what was asked here at the front. We need to create a column with this value because this will be useful later on. Exactly, so now what's the method that you use to create a single new column? Assign, yes, so we can use assign. So we do something like Pokemon.assign, and then we can do total equals, and we can grab this expression. Oops, what did I do? What did I do? We can grab this, copy, and paste, and this should produce a new column on the right. And because we want this column, we can just reassign. And then when we're done, we should have a data frame with 18 columns. We started on with 55, we got down to 11, and we've added a couple of them. We're now at 18. Okay. Everyone good with this? Excellent. So now let's do a vote. We're getting close to the, well, first and foremost, very close to the coffee break, which I'm looking forward to because of the break part. I don't really like coffee, but I like breaks, they're good. And now we need to do one of two things. I'll either speed up a bit for the next 15 minutes because there's two very interesting and important things I want you to take a look at, and then we will have 90 minutes for plotting. Or I keep more or less the same pace. When we start the second half, we'll do maybe 15 minutes of pandas, and then we will do the remainder of plotting. So would you rather I speed up and do 90 minutes of plotting, or would you rather... So this is just the two options. Keep up the pace and then do a little bit less plotting. So who's up for speeding up and 90 minutes of plotting? And okay, this is gonna be like 50. And then who's up for a bit less plotting and same pace, less plotting? Right. Well, no, it wasn't. Okay, so speeding up a bit won. The good news is if I go too fast for you, then there's a long break. I'll be kind of around so I can talk to you during the break. Alright, so let's speed up a bit, because what I want to do now is I want to take a look at two other things. We'll take a look at... It's actually more than two, but in my head it's two big things. So I want to take a look at columns that should have been Boolean columns. We'll see how to convert them to Boolean columns, because if you remember in the beginning we had no Boolean data type, only integers, floats and objects. So we'll do the conversion, and then we'll take a look at how to use Boolean series to do data queries, to actually take a look at your data and slice it to pick out just interesting pieces of your data. And we will also take a look at categorical data and how to create a series that's categorical, what that means and how to do it. So that's the plan for the next 13 kind of minutes. Okay, so let's start with Booleans. Let's take a quick look at our columns. And there's 3 columns here that start with an is. And these 3 columns, they're supposed to be Boolean columns. And actually, if you take a look at, for example, Pokémon is mythical, so let's just take a look at one of them. Actually, the summary here only shows zeros. But that doesn't necessarily mean that I only have zeros there, right? So what I can do is I can do dot, so on a series, dot n unique to compute the number of unique values I have. So there's 2 unique values in that series. Given that I've talked about Booleans, given that I told you that we want to create Boolean columns, that there's only 2 unique values in that series, and there's a bunch of zeros there, who can guess what the other unique value is? It's a 1. Excellent guess. Let's check it. You can do also .unique to get the unique values. Okay. So this column only has zeros and ones and it should really be a Boolean column. So what you can do now is you can take a column, and to change its data type you can say .as type, and then you type in the name of the data type. So the method as type will take a data type name and it will convert the series to that specific data type. Now at this point, taking a look at the bool there, you should know 4 data type names, which are the object, int64, float64, and bool. These are the 4 names you've seen so far in this tutorial. And when you do the conversion, now you should have a bunch of falses in your screen. Is this working for you? Okay, would you be so kind as to convert maybe the is legendary column to a Boolean data type, please? Is it working for you? Excellent. Now what I'll do is, instead of doing these 3 columns one by one, I'll do them all in one go. And the way you can do it is, for example, the data frame also has an as type method. And the way this works is you give it a dictionary with column names and corresponding data types. So I can do is mythical colon bool. I can do is legendary colon bool. And I can do is, what was it, sub-legendary colon bool. And if I do this, and if I run it, and if I scroll to the right, I can see that these 3 columns now hold a bunch of falses and trues. Excellent. So now I'll do one final thing. This is sub-legendary, is legendary, is mythical. There's some Pokemon are less, sorry. Some Pokemon are more common than others. There's a bunch of them and you can find them easily. And some of them are very special, very rare. There's like 1 of them. And these are the legendary, mythical, sub-legendary thingy. It's a flag for very special Pokemon. And to be honest, I don't really care about the difference between a legendary or a mythical one. I just like to have a global flag that tells me if it's a legendary Pokemon or not. So what I want to do is I want to boil these 3 columns down to a single one. Okay? I don't care about the distinctions. I want to grab all of them. And the way I want to do this is, if a Pokemon is any of these 3, I want to mark it as special, and if not, it's not special. Okay? So what's the Boolean operation I want to apply across each row to figure out if I should have the special flag on my Pokemon or not? Yes, it's an OR. Do you see why the OR is what I care about right here? For example, is the first Pokemon special? To check it out, I'll do false or false or false. And false or false or false is false. So this one is not special. But this one, for example, true or false evaluates to true. So it is special. So I want to do this. Now, first and foremost, I need to save. I need to reassign this because I want the columns to be saved as booleans. Now, if I go ahead and I do something like is mythical or Pokemon is legendary, Pandas complains. Because this OR, it's actually very interesting, but it's not the main point here, so then you can come and ask me later if you care about the reason why this is actually an error. But what I want to do, the operator I want to use to compare 2 columns and OR their values, is the pipe operator in Python. This will give you a Boolean OR across the columns. And if you do it one more time, you can do a Boolean OR across the, if I manage to spell this right, you can do a Boolean OR across the 3 columns. You can even see there's a couple of truths here at the bottom. But then again, I don't know, spelling this out, what if there were 6 of these? Would I have to write down all of them with the ORs and the Pokemon? Absolutely not. What you would do is, now notice there's a double bracket here, you would type the list of the names, because there's a series method called any that will apply a Boolean OR across the values. But if I do an any like this, I get 3 values only. Why? Because what's the default axis of these operations? Exactly, which is the vertical one. So I'm going across the series, and what I want to do is I want to go across the rows. So this lets me check if a Pokemon is special or not. Is everyone on board with this operation? And now what I'll do is I'll assign this result because I care about this column. Pokemon equals Pokemon.assign. Let's call it legendary. And now the really fun stuff begins. Or this is one of my favorite things when working with Pandas. It's about to get really interesting. So now the question for you is, which Pokemon are special? Which Pokemon are legendary? How can I figure out how many of them are there? Well, the how many is actually easy. So if you do something like sum, if you have a Boolean series and if you sum it, what do you get? The number of hits in that series. So there's 85 legendary Pokemon in total. Do you understand why that's the case? Okay, brilliant. If you do, let me copy this. If you do .mean, you will get the percentage of legendary Pokemon. So far so good? And now the best part, I hope you're sitting for this. If you use a Boolean series to index into the data frame, Pandas will use the true and false values to pick the specific rows that it will show you. So notice how by using Pokemon legendary here inside the square brackets, remember that there were 85 legendary Pokemon, and when I do this indexing, I get the data frame with 85 rows. And if you scroll right, every single one of them will have the true status on the legendary series. Do you all see this? Okay, brilliant. So now I have a question for you. Can you please let me know what's the first Pokemon that has a total, remember that there's a column called total, that has a total value greater than 600, strictly greater than. Let's see if you can figure out how to get this answer. What's the very first Pokemon with a total greater than 600? Sorry? Mewtwo. Okay. Does anyone else get the same answer? Does anyone get a different answer? Okay. So the way you could do this, for example, is by taking a look at the total column, checking if it's greater than 600, and comparison operators broadcasting also works with them, and then use that as an index into Pokemon. And that gives me a bunch of Pokemon, and the first one really is Mewtwo. Okay? So broadcasting works with comparison operators just fine. And this is how you can use Boolean series to do some querying in your data. You just write an expression, you combine different columns, different series, different conditions, and then you can take a look at the resulting data. I find this a lot of fun, honestly. Okay. Everyone on board with this? Brilliant. So then, the last thing I wanted to take a look at... Oh, and maybe we should just very briefly... Let me just tell you, because it's common. So, the Boolean operators were the pipe stands for OR. The ampersand stands for AND, and the tilde. So actually I should just, so it's the pipe, the ampersand, and the tilde. This stands for not, this stands for and this stands for or. Okay, these are the three Boolean operators. So for example, which Pokemon are not legendary? Oops, these are the ones. Okay. Alrighty, so now let's take a quick look at categorical data before we go on our coffee break. So when I say the words categorical data, does that ring a bell? To some of you maybe? Have you ever filled out a form where they ask you for your name? Okay. What's the typical experience when you have to type out your name? It's going to be a text box and you just type stuff, right? If you're unlucky like me, it's going to complain because your name has weird letters and some forms don't like, I don't know. Or maybe your name is too short and you can't have a name that's too short. Please, come on, be serious. I don't know. It has happened to me. Not the short, but the all sorts of interesting things. But it's a text box and you just type. Have you ever been asked your nationality, for example? And what's the typical experience of that? It's a drop down with a bunch of countries. Because there's a predefined set of values that are expected as an answer, right? And so not only does it make it easier for you if you have a drop down to select from, but also it helps prevent, I don't know, typos. Because if you were to type, hey, I'm from Portugal, and then you misspell it, and then someone would have someone from Portugal instead of Portugal, that would be upsetting. So when we talk about categorical data, we talk about data that's like this. When there's a predefined set of values that make sense for that variable, and it doesn't really make sense to have anything else other than that. Okay, so for example, your nationality, that's a good example of a categorical variable. And you don't need to know this because you don't need to know about Pokemon, but for example in here, the English name, this is a good example of something that's not categorical, because Pokemon names, they can be whatever. But this primary type here, this is supposed to be a categorical variable. And I'm letting you know. I know Pokemon, I've spent way too much time playing, and this is supposed to be categorical. You're not supposed to be allowed arbitrary values in there. But if I check the data types, my primary type is an object. So this is general, and I want this to be a categorical variable. I want to change this. And so one thing you can do, and so sorry, there's two advantages to doing this. The first one, it's kind of already implicit, and that is it helps prevent errors because you specify the valid values, and if at a later point you try to set a different value that's not valid, it's going to complain. But also, if you change a variable from objects or string to categorical, Pandas is able to save a lot of memory. Because for the strings, it's going to hold the whole string, but if you say there's only 18 different values, because there's how many there are, there's only 18 different values, and Pandas is able to optimize away lots of space, because it says this is value 3, and then there's like a small mapping that says, oh, 3 is actually this one. Okay, so it's much easier for Pandas to work with categorical variables. And just so that we take a look, a good indicator that a variable could/should be categorical is if the number of unique values, this isn't always the case, but it's a good rule of thumb. If the number of unique values is kind of small compared to the total number of rows, it may be a good indicator that this should be a categorical variable. And these are the different values that we have. So what was the method again to change the type of a series? Do you remember? As type, yeah. So if I do Pokemon primary type, and if I do as type and then category, then the output here of this series, the beginning still looks the same, because visually in the values there, the grass, fire, I don't see anything different, but at the bottom I see the name length D type from before. Now the D type says category, and then there's an extra piece of information. It says the categories are 18. They're generic, so they're the default. The data type of the category values is the default one because there's strings there. There's the bug, the dark, the dragon. so on and so forth. Okay, so does this conversion make sense? Brilliant. So now please use assign to save this as the primary type. So now I want you to override the variable, or maybe just use the data frame as type method. Just save this data frame with this column as a category, please. So one way to go about this would be to say Pokémon equals Pokemon.asType, and let's map the primary type to a category. That's one way to go about it. Now I just scratched the surface of categorical data types, because there's lots of things you can do. They can be sorted or not, and maybe sometimes you know something is a categorical variable but you haven't seen all of the different values yet. For example, out of all of the attendees of PyCon US, I'm sure we've seen plenty of different nationalities, but I would also bet you that we haven't seen all of them. So not all of them are represented. And if you were to do this conversion here, Pandas has no way of guessing what values are missing, right? It just took all of the values it sees and it assumes they're the valid ones. But if there are values missing, you need to specify it. Okay? So this is just scratching the surface so that you know there's such a thing called a categorical variable in Pandas, and then it's up to you to find out more about this. Now, I'm 6 minutes past the coffee break. I apologize for that. So let's do coffee break for now. And so it's 10:36. Let's do 11:05. So at 11:05, we will resume, if that's okay with you. Alright, so what we'll do now for the next 85 minutes is plot. That's it. And before we start, I want to really drive home the point that I was building up to during the past 95 minutes, which is the fact that everything we did was not modifying the data frame in place. Remember, I kept saying that. So there was a point to that. And so what we will do in the first 60 seconds of the following 85 minutes, I hope you're keeping track, is redo everything we did in one fell swoop. So remember how we started by reading the data? So then what we did was, or rather what I'll do now is write in a single go all of the transformations we did, all of the ones that we care about. Yeah, in a single go, and then you will see why we care about doing these copies. So we started by grabbing the columns that we liked. So that was the English name, that the primary type, and then the stats, the special attack, the fifth, the special defense, and the speed. We cared about the soon-to-be Boolean columns, is sublegendary, is legendary, and is mythical. And I think that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Exactly. Then what we did was we converted their types. I'm not necessarily saying things in the order we did them, but in an order that makes sense here. So we converted types. We saw that the primary type, we actually wanted it to be a category. And whoops, wrong button. And then the is columns, the is sublegendary, was a Boolean column. The is legendary was a Boolean column, and the is mythical, what was it? It was a Boolean column as well. So we converted the types of these columns, and then we joined this data frame with what? With the computed stats. So we have a list of stats. I'll just jot it down here as well. The attack, I don't feel like writing this down again, so I'll just copy and paste. right? So we had these 6 stats. So what we did was we multiplied by 2 all of the stats, and then we added a different number for the HP, and we added 5 to all of the other stats. And we had to specify a suffix because otherwise there would be an overlap of names. So we just used final, for example. And then we assigned a couple of columns still. So there was the total, which was the it was the sum of the stats, but across a specific axis, right? It was across the rows, so axis was equal to 1. And there was the legendary column, which was the .any, if you remember, because we wanted the Boolean or across the is sublegendary, is legendary, and is mythical columns. And we also had to do that across axis equals 1. And I think that's it. And I get the key error because I did something wrong. English name, Pokémon. Of course, this was not going to work on the first try. Was it N name or no? It's English name, so that's correct. English name, primary type, also correct. HP attack, defense, SP attack, SP defense, speed. Sub legendary is mythical. Brilliant. Where's the issue? Silly me, sorry. When you want to grab multiple columns, it's supposed to be a list of the column names. So I forgot one level. And now we have something that doesn't have a... I need to sum, and it's the axis, that's 1. And then I need the any dot. Okay, so this thing here, I'll zoom out for a second so that we can see the whole thing. This chain of transformations and method calls and transformations I think is the best word. This chain only works because every single step creates a copy of our data frame. And so there's a blinking lights in the ceiling. It's gonna in 80 minutes we'll have a disco here. Disco party. So there's a so what I was saying, sorry, I get distracted way easily. So the chain of methods here, the chain of transformations, only works because every single step produces a copy of our data frame. And I think, so this is subjective, but I think that this piece of code looks really neat. You know, we did a mess up there, we did lots of experiments, we tried things out, and then when we figured out what we really care about, and now that we're ready for plotting, we just jot this down. If we wanted, we could delete everything else, and now we would have a clean, decent, readable way of preparing our data for the analysis that comes next. So you don't have to agree with me, but this is my personal opinion, and if you can, just do this, because it looks good and it's very easy to read and it's very easy to modify. You can add steps in the middle, in the end, in the beginning, very easily. You don't need to type this because this should produce the same data frame that we had before, and also by this time it should also be in the GitHub repo, so you don't really need to type this out right now. I just wanted you to see like the way it looks on the page. Okay, point taken. Brilliant. So now let's do plotting. I'll zoom in again, like this. Again, the first step is making sure we can import the things we need. So what we'll do is we will import matplotlib.pyplot as PLT. Again, another very important convention. You will have to face the rage of the internet if you don't import matplotlib.pyplot like this. And this PLT is the submodule that we will be using to produce our plots. Just make sure that this works, that there's no import errors. It's working fine? Alrighty. So then, whenever you want to write a plot, you will always start with a line of code that's similar to this one. Fig, ax equals plt dot subplots. And if you type just this, and if you press enter, if you run your cell, you will have an empty plot right in front of you. if you're running a notebook. If it's a Python script, you might not get the empty plot in your face. But for people running notebooks, if you type this, you get an empty plot, correct? Okay. So what's this plt.subplots and what's this fig and what's this AX? I'm sorry, Jim, is there any way we can turn off like that light bulb specifically, or do we lose a lot of light? Let's see what happens. Because believe it or not, it really is upsetting and it bothers me a bit. Jim felt lonely there. I just needed to give Jim some work. Now it depends on them. For me, it's fine. Is the lighting good for you guys? Is it better now? We should have done this earlier. Okay, thank you, Jim. Perfect. Alrighty, so if you want to take a nap, I feel like now is also a good time. So now I need to dim the screen on my phone and on my computer. Okay. So now that we've set the mood, let's take a look at fig and AX. So I'll start by taking a look at the types, because at least it will give me a name that I can call these things. So fig is of the type figure. Okay. And AX is of the type axis. And these are matplotlib types. And essentially, what these are is, on the one hand, the fig is a reference to this figure, which is the matplotlib object that's going to represent the whole thing that's visual. So if you were to print your plot on a piece of paper, everything that's printed, the visible things that the things that are there, they're inside the figure. So the figure knows of everything. The figure is aware of everything. And this AX right here is aware of the plot. The thing with the axes, with the numbers, eventually with the lines or the diagrams or whatever. And to be honest, they kind of feel like the same at this point. Because the only thing I see in my figure is a plot. But eventually you will have figures with multiple plots, for example. You might have two plots side by side, one on top of the other, or two here and then a larger one at the bottom. And when you get to that point, you will have one of these axis objects for each of those plots, because for each set of axes, you may want to plot a line here, and then some bar plots here, and then some circular plot here. But this whole thing is inside the same figure. So your figure will be aware of all of this, and then you will have one of these axis objects per each plot. Okay? So that's why there's two things, but throughout our tutorial we will only care about the AX, because we will have single plots. Okay? So far so good? Alright, so then the AX is the object that contains the... when I change the... okay, no, you can see the indicator, but it doesn't change the... Okay, so that's visible for you, right? It's a good brightness. Okay, so now the hello world of plots is something like fig equals AX... Sorry, fig, AX equals plot.subplots, and then you do ax.plot and then something like range 10. This should produce a plot like this. Not very interesting, but at least it works. Does everyone get a plot like this? Remember, now it's very important, whenever you want to create a new plot, you need to call subplots again, because this initializes the figure and the plot. So for each plot we create, we will always start with this. And then ax.plot, range 10, range 5, range 11, you should get a straight line pointing up and to the right. Is that what you get? Okay. So now let's make it more interesting. By the way, notice that range is a Python built-in, right? So range is not special. It has nothing to do with matplotlib. It's Python. Now let's do the following. 10 is a big number. It's very big. So let's just do range 3. Actually, if you rerun it, the plot should more or less look the same. And now, to the left, left or right? I'll let you pick. Left or right? Right. Okay, so then to the right of range 3, let's write your favorites, your 3 favorite numbers. You write them. I don't care what they are. For now, I don't care. Just write 3 numbers in a tuple. One number, one number, one number, and then rerun the plot. And see if the plot changes, because it should. Does it change? Okay, so if I do 3 numbers here, let's do 42, 73, and then 0. If I rerun this, now I get a line like this. Yours will probably look different because you probably picked different numbers. Do you get a different plot? Okay, so why am I showing you this silly plot? Well, for 2 reasons. The first one is that I want you to see that the plot method either takes... Okay, so now I don't really know your background. So when I talk about y values, do you know what I'm talking about? It's fine if you don't know, but you just need to let me know. Okay, thank you. So but we are all familiar with the idea of 2 x's on the plot. So on the bottom we see numbers there, 0, 0.25, 0.5. The bottom axis that's pointing to the right, or that's horizontal, we call that the x, as in the letter x, axis, and it contains the x values, pause. The vertical bar on the left with numbers 0, 10, 20, 30, we call that the y-axis, y as in the letter y, and it contains the y values. And then what are the x and the y values? They're actually the points, they're the locations in the plot that you care about. So, for example, let's make it a bit more explicit, or very, very obvious. So range 3 is actually 0, 1, 2. And so what I'm doing now is I'm saying that for the x value 0, or to the x value 0, I want to associate the y value 42. And so if I go to the x-axis on the bottom, I see the 0 here. On the y-axis, I have the 42 more or less here, and so they meet at this location. That's the first point of my plot. If I scroll up, there's the 73 and the 1. So for x1, I want y73. So y73 is somewhere around here. And if I scroll down in a straight line, I get to the 1. Okay. So the values on the left here, these are the x values. The values on the right are the y values. So for example, if I want this end point to be at the same height here, I need to change this 0 to a 42. And now I have a triangle, a beautiful triangle. Okay, so plot takes the x values and the y values, or if you remove the x values, it just assumes they're the first integers. So that's why when we did range something, it just worked out of the box. And now all of your plots can be customized. So when I was doing this thing of let's take a look at the different axes, see where the points are, there's a way to make it more visible. And so many plotting methods, so the plotting methods are the methods on the AX variable. They usually have the name of a specific type of plot. This is just a regular line plot, so we call it plot. And they will have keyword arguments that let you customize your plot. So for example, if I were to type, let's get this right, I think it's markers in the plural. Yes, no, it's not, it's singular. So if I type marker equals, for example, O, so now I get these little circles in the points that I care about. So go ahead, try that, the comma marker equals O. Make sure that it works. Okay, now I'll tell you the following. There's a bunch of different letters and characters that work as different types of markers. Go ahead and try random letters and random characters there to see if you can find different markers. Because there really is a bunch. Okay, have you found any other marker? Just let me know what, sorry? X. So the X produces these crosses. More. 1. Star. Literally for the star. There was a D, I think, for the diamonds. And someone from the back shouted something that I couldn't get. OS for squares. Okay, so there really is a bunch of markers. Of course, they're documented, so you don't need to guess which ones you care about, but they typically, they're either like the first letter of the shape, so S for square, or they're very visual. For example, the V is going to be an upside down triangle, and from this one I'm guessing you can get the triangles pointing to all four sides. So a triangle pointing up and the triangles pointing to the sides. Alright, so there's always lots of customization options. Obviously we won't go through all of them in this tutorial because we would do nothing else. So the point is just open the matplotlib documentation, check the plot type you want, and just take a look at the things that you can customize. Now what I'll do is I'll show you something else. So I'll copy this line, this ax.plot, and I'll paste it below. And now I'll change the values here. And you can change them to whatever you want, just change them. And if you run this whole cell with two calls to ax.plot, you should see two lines on your plot. Do you get two lines on your plot? Why do you get two lines on your plot? Because you called the .plot function twice. So the ax is a reference to the x's, and what you did was you called a method on those x's twice, and it's the same set of x's. So obviously, well, maybe not obviously, but now you know. So then the things you're plotting go on the same set of x's, therefore they show up on the same plot. And if I were to keep going, I would get more and more plots, more lines, sorry. And matplotlib does us a favor and colors them differently. Obviously you can control that as well. Now I have one to the right, because what I changed was the x values. And also the marker, sure. Okay, so you can just keep going. Now there's one thing, I need to do something to make our lives easier. And that is, when you create these subplots, when you initialize your variables, you can specify some overall configurations for your plot. And I want to set three things here. The first one is the fig size, so the size of the figure, which is important for when you're actually printing your plots. And I'll set it to a size that can show a plot on this screen without having to keep scrolling back up and down. And this also controls the aspect ratio, so you can set it to something you like. I'll set the face color, which is going to set the color of this region around the plot. And it's useful because if you save this as an image, by default it's going to be transparent. And so if you set it to some color, then it's easier to include your plot, for example, on a blog article or something. And then there's this layout thing. Now this is the fun part of these defaults, because the documentation really says, yeah, you should really use layout equals constrained unless you really know what you're doing. And so I use it, but I don't really understand what it does. I'll be honest with you. But the documentation just say, yeah, please use it. And so I thought maybe I would add it here. But throughout this tutorial it probably shouldn't make a visible difference. And now you can already see I ran it, and now the plot is smaller and a bit more stretched horizontally. And also you can see the color, the white smoke around. Alrighty, so this is working fine for you as well? Whenever we initialize the plot, I'm just going to copy this bit, so you feel free to do the same, just copy and paste. Okay, so now let's create a different plot, one slightly more interesting plot. Again, the point of this here is that matplotlib and pandas, they interact really well, but there's nothing special about using pandas values inside matplotlib. Matplotlib just expects iterables, things with values, and as long as you provide it with iterables, they don't have to be pandas things, okay? Pandas just interacts well with matplotlib, but they're two separate things. So now what will we plot? If you remember, we had actually I don't think we do. we don't because I got rid of it. So sorry. Can we change it? Yes, we can. But it's not gonna look good. Okay, sorry for this. Actually, let's do a first. Yeah, let's do a first line plot with this. That's gonna work fine. So let's copy this boilerplate. Let's paste it. And there's later down the conference there's gonna be a poster session about, like, because you always want to use this, maybe you want to save it in a configuration file or elsewhere, you can do that, so you don't have to really copy and paste this all the time. So check the poster session on matplotlib. But for now I'll just copy and paste, and now what I'll do is I want to plot the HP of all of my Pokemon. I want a line plot that goes up and down with the HP of all of my Pokemon. So I give you a hint, it starts with ax.plot, so what do I need to type after that? Give it a go and produce a plot with all of the HPs. Did you get it? It should look really bad. But if you've got something that looks really bad, at least you know you got the correct thing. So you just do Pokemon dot, what did I said HP, right? Pokemon dot HP, and there you have it. Of course it looks terrible because it's a lot of values crammed in a very small space, but it's there. And this shows the thing I was saying, which is Pandas and matplotlib, they interact rather well. So this is a series, it's a one-dimensional thing, and matplotlib needs one-dimensional things to make plots. Well, not really, but for the line plot it does, which is the sequence of values, and so that's why you get that thing over there. And you can actually see a couple of peaks, for example, for Pokemon that have a large value of HP. This is unreadable, but it's there. Now, no plot is complete without three things. And they are the title, the x-axis label, and the y-axis label. Exactly. Because there's two types of people in the world. Those who can infer from missing data. Okay, so you got it. If you're sad, if you got the joke, regardless of whether you laughed or not, then you're good. If you didn't get a joke, yeah. So let's set the title to, I don't know, HP of all Pokemon. Let's set the X label to what? To Pokemon index, for example. And now let's do what? What do I need to type here for the third? Set Y label. Let's call it HP or base HP. Okay. It looks terrible, but at least it's complete. Just make sure that you can get something like this, please. It's working for you? Okay. Do you have any questions so far? It's not, yes. Excellent question. Okay, I like this question. So, tell me, are you surprised by the fact that if I type something like 10 plus 5, I get a 15 there? Okay. What about sorted, range, reversed equals true? Reverse equals true. Does it surprise you that there's an empty a list there? Okay, everyone's kind of okay with the fact that there's something being printed there. Now, what if I do something like this? Are you surprised by the fact that it no longer prints? Okay, so then it's exactly the same principle. Jupyter Notebooks by default will print the value of, if the last line of code was an expression, it will print the result of that expression so that you can see it. So for example, function calls are expressions, and so you typically see the result of the function call. But an assignment is not an expression, so there's nothing to be printed. Matplotlib is a Python module. So what I'm doing is I'm writing Python code. When I do this, this is a method call. I'm calling a function on the access object, right? And functions often return results. And the return result of this thing is the piece of text that was created as the Y label. So that's why there's a text 0.5 base HP. Notice how, and it's no coincidence, the thing you typed here is what shows up there. If you swap these two, now the last one is the X label. Notice how the plot obviously still looks the same. What got printed now was the numbers are different, and so is the text. So the notebook is just showing the result of the last expression. Now it's a bit upsetting because it's being shown side by side with a plot, but it's not part of the plot, and you can get rid of it, for example, by assigning the last expression to something, and now it doesn't show. So the plot is being shown because Jupyter thinks it's a good idea to show you the plot, and sometimes it looks odd because it's also showing the last matplotlib expression, but it's just that. Okay? But this also goes to show that there's something interesting going on, which is I could do this, and then I could manipulate the text by calling methods on the text. And this is important, okay? Matplotlib is still Python code, so everything you know about programming applies here. Okay, just don't forget that, because sometimes people will ask interesting questions because they forget that this is still code. I mean, if you need to do something 10 times, use a loop. Don't write it down 10 times. Loops work, it's Python, okay? I'm assuming I answered your question. I took a bit, but it's actually a very important thing. Okay, any more questions about this? So now what I want to do with you is build up to the best looking plot we will do today, and then from there it's just gonna go downhill. Okay, so let's do an interesting bar plot. I cannot describe the sense of happiness I felt when I made that plot. I felt so happy. Maybe it's not a big deal for you, but I really enjoyed it. So I'm gonna work with you to create that plot. So now what we will do is we will focus on our primary type variable. If you recall, it's a categorical variable because we set it to be a categorical variable. And the values here that we have, this bug, dark, dragon, electric, etc., for people that don't know Pokemon, and if you know Pokemon, hear my description and then help me out, because I thought long and hard how to explain this to a person that doesn't know the franchise. So I would say that these are kind of like clans, and each Pokemon belongs to one of these clans, as in CLAN, and what is more, they're kind of like, so these tribes, but they're tribes also in the sense of do you know the 4 elements? Air, wind, water, and earth. So these are like 18 elements, quote unquote, and each Pokemon belongs to one of these clans / elements. There's more to it, but for the primary type, let's think of it like that. They're the clans of the Pokemon. And now what I want to do is I want to study the distribution of Pokemon per clan. That's it. And actually in Pandas it's very easy to do this, because what I can do right off the bat is do Pokemon primary type and then dot. Oof, I never remember. Is it value counts? Yes, I got it right. You can do Pokemon primary type dot value counts, and you get the count per clan. And now I know that in the water clan there's 123 Pokemon. In the normal clan there's 109, so on and so forth. Please make sure that you get something like this, a count like this. Because now what I want to do is create a plot to show this information. Does that sound like a good idea? Okay, so let's present this information in a decent plot. Now, there's one thing. Well, there's plenty of things. Let's go with a bar plot. Does this sentence sound reasonable? Does this choice sound reasonable? A bar plot to present this type of information. Okay, do we need to go over why we want a bar plot? No, okay. later I'll share a link with a very nice resource where you can check a bunch of different types of charts, plots, and it helps you pick, like for the variables you have, it lets you pick a suitable type of plot. But let's go with a bar plot. So if it's a bar plot, who can guess the name of the method that the AX has? Bar. Yes. Guessing can be fun. I mean, just don't be afraid. So let's go and copy the boilerplate to initialize a plot. And now let's do ax.bar, and let's just type some of these values to see what we've got. So let's just type the first three. So 123, 109, and also 86. So if you do this, it doesn't work. Okay? And it says that the bar method is missing one required positional argument, which is the height of the bars. Which is kind of weird because what I did was specify the height of the bars. So actually what we conclude was I'm missing something to the left of this argument, and that's the positions of the bars. So what I want is I want to specify the center of each vertical bar and then the height of each bar. And for these 3 bars I can just do something like range 3. So if I do range 3 and if I type 3 numbers, then I get this. See if you can reproduce this, please. Is it working fine? Okay, so now the challenge is, it shouldn't be obvious, okay? Or it's not necessarily obvious. So the challenge now is, instead of typing the 18 values here, because you already know that's a bad idea, try to figure out a way to use this thing to plot the 18 bars here. So see if you can modify this to put 18 bars on the screen. Give it a go. I'll give you some seconds to do it. Feel free to let me know if you make it work. Did you get it working? Okay, brilliant. So what we need is, we need to realize that that these value counts, this is actually a series, so it's a one-dimensional thing. And matplotlib knows how to plot one-dimensional things. So instead of typing these 3 values here, I can just put the value counts there. And now instead of range 3, I need range what? Exactly, why 18? Yeah, exactly. Now there's one thing there's plenty of things I don't like about this plot. But there's one thing I don't like about this plot. And that is, I don't like this range 18 here. It's not easy to guess what I'm thinking of, but who can guess why I don't like the 18 here? Yeah, it's hard-coded, exactly. So the thing is, if the data above it changes, if there's a different number of Pokémon types, then suddenly my plot breaks. So what I'll actually do is, I'll go ahead and I will extract this primary type series because I'll be typing it a lot. And what I'll do is primary type dot n unique, so the number of unique values, and here primary type value counts. So there you go. Same plot, I just removed the 18 and I typed this in. It's more typing, but at least my plot won't break in the future. Okay, so now, what's missing from this plot? And? Well, also that, but I said that no plot is complete without three things. The labels, there's two of them, and then the title. Okay, so before making it look pretty, we need to make sure that it's actually a complete plot, a full plot. So let's do a title, which is going to be distribution of Pokemon per type, for example. And then the set X label. What's the X label actually supposed to represent? The different primary types. And the Y label is the count of Pokemon per type. So let's go with count. Whoops, what did I do wrong? It's not title, sorry, it's set title. So now you should get something like this. Make sure you can get that. You can get this plot. Okay, given that no one is screaming, I'm assuming it's working for everyone. Yeah, I'll give you 60 more seconds because I'm going down there. Jim, I need to ask you for a favor. Can I get Jim to take a picture from the back? You don't. Would you guys be okay with having your back on a picture? It's not a joke. Can I post it online? The backs of your heads. If you want, you can step up for a second. Jim, can I ask you to take a picture? Because I mean, I have a full room at PyCon US, and I just have to celebrate that, you know, for the internet points. It's black and white, but don't worry. If you get like all of the heads, like the the greater the number of heads, the better. Yes, to make it look like it's dense, you know, like densely packed. Okay, now I'm pointing. Yeah, okay, thanks, Jim. Now I need that because those are my notes. So hopefully you had time to complete the plot. Thank you very much, Jim. Now, someone suggested that one thing that was missing here is labels down here. Because maybe you know, but I have no idea what the type 10 is. That doesn't make a lot of sense, right? I specify the positions. I specify the positions of the bars, but what I really want down there is the corresponding types. And to make it even more obvious that there's an issue, the label of the x-axis is primary type, and what I have there are numbers. So there's clearly an issue there. So let's fix that. I'll grab this. I'll have it here so that then you can also see a progression. And our bar method accepts another argument. Let's maybe spread this over the line so that you can see how many things I'm specifying. There's an extra argument there called tick label. And these are the labels. Is it too far down? Okay, is it better now? Okay, sorry. And the tick labels are the labels for the ticks. What are the ticks? They're these little lines here where there's a number. Do you see them? So what I want to change is the text below each of these ticks. And one way to do it, there's a bunch of ways to do it, but really what I want is I want to be able to specify those 18 values for the category. So if you go to the primary type, this was the series with the categories. If you do primary type dot cat dot categories, you get the 18 categories there. Okay, so this is a way to access all of the categories of my series. So what I want to do is I want to take this and plug it into the tick label. because then if I do, I get an excellent plot. Yes, thank you. One step at a time. But at least now I got the text there. Did you get the text there? Okay. So now what's the obvious issue with this plot? Exactly. It's yes. You shouldn't get that yet. Let's bottle that up for a second. Okay, so what's the issue? It's never mind that issue. What's the issue now? It's unreadable. You're not supposed to be able to read what's happening yet. Okay, so let's go down that road in a second there. So yeah, it's absolutely unreadable because the text is jammed together. So how can we fix this? What would be your not in terms of code, but in terms of visual changes? What would you do? And don't sorry. Oh, switch the axis. Oh, okay, that's a good idea. Let's leave it to the end. You're having way too good. Your ideas are too good. Isn't there? Okay, so maybe it's yeah. Yeah, okay, increase the width. That works, but it looks kind of weird. Now it's readable. I find it a bit weird, but it does work. But what I wanted to the route I wanted to go down was the rotating the text. Okay, so let's rotate the text. Let's do it. Can I do it? I think I can do it. So let's take this plot and let's make a better version of it. So our AX object has a method called ax.setXticks. And what are the ticks? Again, they're the small lines that indicate the x values that we care about. And so who can guess what this method does? It lets you set the ticks for the x-axis and control the way they look. So how many ticks do we want? We want one per type. Right? So we want one per type. So these are the positions of the ticks. Now, what are the labels that we want? We want, again, the categories. We want the categories. And now we want to set the rotation to 90 degrees. And thankfully there's no European to American conversion I need to make there. It's just 90 degrees. And then it doesn't work. Brilliant. What did I miss? It's not label, it's labels. The labels of the ticks. Now see if you can do this, and do me a favor and try to make the same plot, but with the text, instead of going upwards, going downwards, and see if you prefer it that way. And let me know if you like it, if you prefer it this way or with the text going downwards. So do you prefer it this way or the other way around? You're still typing, right? Sorry. I'm too excited. Is it working? Okay, so what do I need to change in this piece of code if I want my text to go downwards? Yeah, okay, exactly. So if I change this value I'm changing the orientation of the text. Can we see that now it's flipped the other way? Okay. Now I think it's subjective whether you prefer it this way or the other way. You could also try something like 45. I don't like it because the spacing is odd, right? The spacing is odd and there's still a bit of overlap. So let's go with 90. Is that fine? Yeah? Okay. So now, cue my friend over here in the front. What's the issue with this plot now? Sorry, what? Ah, exactly. Bug doesn't have that many. So now, the plot is wrong, which is great, right? If you go back to the value counts, water is the primary type with the most Pokémon. However, the label water is at the end, and instead we have a bug here. And that's because, as pointed out by my friend here, is if I take a look at primary... Actually, can you tell me why the labels are wrong? Can you see why? Sorry, I heard someone say something. They're in alphabetical order. Yeah, they are. Yes, they are. Sure, then why aren't the bars also in alphabetical order? So why... There's obviously a mismatch, right? But what's the source of the mismatch? Ah, okay. Exactly. So the mismatch comes from this line of code and this line of code. So on the one hand, I set the labels to be coming from this value, and this is in alphabetical order, the list of categories, and the values themselves, the heights of the bars, they come from this piece of code, and by default value counts will sort in descending order. So one way to fix it would be, for example, sorted equals false. Sorry, not sorted, sort. Sort equals false. Now it's correct. As in the labels are in the right places. There's another way to fix it, and I think for the purposes of the plot we're making, I think it looks better, which is to have the bars in the order they were and just fix the labels. I think that's reasonable, to have the bars in descending order of count. Are you okay with that change? Okay, so now let's do that change. So let's take this bar plot, sorry, and let's fix it. So I want this to be sorted. Now what I need to do is I need to change this piece of code, this line of code, because this is the assignment that sets the labels, and the issue is here. So I need to put something here that's in the correct order. And I'll give you a hint. If you look at, again, the value counts, do you see the numbers in descending order? Do you see the things on the left that are the corresponding types? Do you see how they're matched up? They're correctly matched, so water 123, do you see that? But sorry, what's the type of primary type? I think I heard it. Right, that's the type of the values, but what's the type of the object? If I typed, it's a series. But weren't series one-dimensional? But if they're two-dimensional, how come? If they're one-dimensional, how come there's two sets of values? So the thing is, maybe you said, I don't know, someone mumbled something. And that's not it's just my hearing is terrible. This is a throwback to something I said in the beginning, hand wavy. Series and data frames have this thing called an index. Each row in a data frame or each value in a series has this thing called an index, which sometimes kind of works as in the actual index of a list, for example, but it's really just a way for Pandas to know what row is which or what value is which. And in this case, in this value counts, instead of giving me numerical indices, so 0, 1, 2, 3 on the left, it's it figures out that maybe a more useful index would be the primary type whose count I'm talking about. And so it has the counts there, but they're not part of they're not the values, they're just the index of the series. And so again, it's for alignment purposes. So remember when we joined two data frames? Do you remember that when we had we joined them? It was literally just putting them together. And it was obvious that we were just putting them together because the order of the Pokemon was the same. But if we took one of them and if we shuffled the rows, we would still be able to join them together because the indices, in this sense, in the sense of the Pandas index, the indices would shuffle with the rows because Bulbasaur, which was the first Pokemon, had an index 0, and if you shuffle the rows, wherever Bulbasaur is, the index would also be 0. And so even if you shuffle them, you're able to match them together. So that's the point of the indices. And in here, instead of giving us random, well, not random, but the sequential integer indices, Pandas figures out it's probably best if I just use the types, the primary types for the indices. And so this is something you can access. These are not the values, the actual values inside the series, those are integers, but we can still access the indices programmatically. And we do that with a dot index, if I'm not mistaken. Yes. Categorical index. So if I take the value counts, I get the index in the order of the index. So we can see that water is first, and then normal, and then grass. And so what we can do is replace the labels here. Instead of being the categories in their alphabetical order, they could be the index of the value counts. And this should fix the labels. Did you follow my explanation? Did you get what I was trying to get at? By the way, for your plots on your laptops, it looks much better if you do fig size something like 8 4.5. It looks much better. It looks less cramped. But for if I do this, then you can only either see the plot or the code. So that's I'm making it smaller, but 8 4.5 looks really good for you. Okay, so please try to fix the tick labels. And give me a nod when they're fixed. A nod or a thumbs up, something. Okay, so what are we doing next? We're adding color to our plot. Now, in the Pokemon franchise, each of these clans has a color. And if you play the games, then sometimes it's easier to see the color than to read the type. It's a very well-defined association. And so it will look good for Pokemon aficionados to have each bar with the corresponding color. So that's what we will do. Now, to make it easier for us, there's in the repo, a couple of minutes, I think during the break, I added a file. I had forgotten that it was necessary, but I added the colors.txt file. And this file, you want to copy the contents. We don't care about the file, we just want the contents. So select everything and copy it. Because that's a Python dictionary that's mapping each primary type to an RGB color. Now, are we comfortable with RGB colors? These hashes and then the letters and the numbers? Okay, excellent. So this is a mapping. I didn't come up with it, I just copied it from the internet, because that's how real programmers work. And what I'll do now is I'll use that information to set the colors in my bars. Are we ready for that? for this step you do need, unless you want to make them up or just copy them at a very fast pace, I need everyone to get the color data. So if you're following along, are you still grabbing the data or do you have it already? Okay, so everyone has it, or at least no one complained. So now let's add the color. How do we do this? Well, I'm not sure if you've been picking it up so far, but there's methods and keyword arguments for everything. So it's actually in my bar plot that I'm going to copy. In my bar plot, there's inside the dot bar, there's a keyword argument called color with American spelling that accepts an iterable. I was thinking it accepts a list of colors. And what it will do is it will take those colors and use them for the bars. So now I think, actually, let's give it a quick try. I think it doesn't have to be the correct length. This is a bad color. FF0000. I think it will cycle through the colors. So how is this? Did I forget? Yes, I forgot a hash there. Yeah, exactly. So you don't necessarily, don't worry, that's not what we're going for. You don't necessarily need the correct number of colors, you just specify some colors and matplotlib will cycle through them. But what we want to do is give it the correct 18 colors. So there was this dictionary here, this type colors data. So if I have a dictionary, how can I access all of the values? With a dot values call, right? Because the dictionary is mapping types to colors and what I want is the colors there. So if I do this, I should have colors on my bars. Now, for Pokemon people, what's the issue with this plot? The colors are wrong. I'm sorry, I'm trying my best. I just keep doing things wrong. So we need to fix the colors, and even if you don't know Pokemon, you could eventually get there. But for example, let's see. If I take a look at type colors data water, this is, if you look at it, this is obviously a shade of blue. It's clear from the hexadecimal code. And if you look at this water thing, I won't say what color this is, but I think we can all agree it's not a shade of blue, right? So there's clearly an issue here. So how do we fix that? Well, the thing is, when I type the values here, this thing gives me the values in the order that I define the dictionary. And that's not what I want. I want the values in the order of the bars, of the value counts. So I need to fix this somehow. There's different ways to do it. I'll even time it. I'll give you 2 or 3 minutes to actually try to fix this. So it's not necessarily obvious, but if you think long and hard enough, you will get there. So I'll just give you a couple of minutes to try and fix it, and then we'll see how we could do it. Can I get a quick thumbs up if you've managed to do it already? Okay. Again, it's not supposed to be easy or obvious at first. Hopefully you've had time to struggle a bit. Now the thing is, what's the actual problem? The actual problem is that the order of these colors is not correct, right? We need to reorder these with respect to the value counts. And this type colors data, this is a dictionary that maps types to colors. So if I use as my source of, if the source of ordering, or if I base the ordering off of this index, which contains types, then if I go over the types in this order, in the order of the index, then I can use the dictionary to map each type to its color in the correct order. So did you get the premise of what we're doing? So now what I'll do is I just copied everything over. Alongside the primary type, I'll assign the value counts to a variable because I'm just recomputing this over and over again. So these are the value counts. And now what I'll do is the colors I want to use, I'll get them by taking the color dictionary and indexing with the primary type that I get by going over each primary type in the index of the value counts. Okay? If you don't know list comprehensions, I'm obsessed by them, we can talk about them later. Now the value counts here, what I want actually is the index, and in here the color, I'll set it to my list of colors. The most important change is this one that comes from this list. Let me just make sure that I typed everything correctly. Of course I didn't. What's p type? P, right, I'm okay. So now you can take a look at the code because the plot now is correct. So what I'm doing here is I'm building a list with the types, with the colors ordered by type aligned with the index of the value counts. And now this should produce a plot, and the water bar should be in a shade of blue, the fire bar should be in a shade of dark orange, reddish orange, electric should be yellow. Just make sure that it runs and it to get the correct colors. Is it working okay for you? And to wrap it up, as in this plot, to wrap up this plot, let's go with another suggestion that we had, which is to flip the plot, to actually flip the plot to have horizontal bars, because I think it also looks interesting. So we had regular bars, now we want horizontal bars, and so the change is actually very, very, very easy to make. We just go to the ax.bar, and instead of bar we just add an extra h. And that's almost all of it. Now if I run this, what's the problem with the plot I get? I think you said the right thing, I just couldn't hear it properly. If we run the bar age plot, if the only change I make is the age in bar age, now I get this. Do you guys also get a messy plot like this? What's the issue here? Yeah, exactly, because now I want my ticks to be on the y-axis, so can you fix that? Just go to set x ticks and change it to set y ticks. And now it's still a mess. What's the issue now? The 90 degrees, we can get rid of them. And it's still a mess. What's the issue now? What, sorry? The what? Ah, sure, the ratio. Okay. Okay. The x and y labels are also wrong. So then it's just a matter of setting it to a better size so that the labels on the ticks look better. But yeah, if I make my plot slightly taller. Now it's kind of readable and I could increase it further. Okay. So actually let me make it look decent, because I said this was going to be the best plot, so it should look like so. Okay, so I increased the figure size to 8,4.5 and it looks like this for me. And now if you want to save it, you just type, I think, let's do fig.save, let's call it bestplots.png. It didn't work. Is it not save? Let me check my notes. Because it feels like it should be saved, but obviously it isn't. I think someone say, if you know it, tell me. Don't let me. Ah, okay. Wait, what? With an underscore? Oh, you were trying to guess. Ah, okay. So it's without the underscore. Okay, so save fig, and now I've saved it somewhere, probably next to the. Can I reload this? How do I reload this? Yeah. Yeah, best plot. Okay. So save fig will save your figure. Were you able to produce this plot? No. Okay. What's the issue? Of course. So you got this one. Okay. I added the letter H to bar, and then it rotated, but it looked bad, so then we had to fix the X ticks because now they're Y ticks. Okay. Yeah, tell me. Oh, wait. Sorry, you're not the same person. Who asked for the place where I rotated the data? Ah, sorry, I was looking at the wrong person. Okay, you got it, because I mean, if you have a mask, I can see your mouth, right? I'm sorry. And now, sorry, you were asking. Why did it? Okay, so on the one hand I get you, but it didn't, because the y-axis goes from the bottom to the top, right? So the bottom is where it starts, and when it's from left to right, it starts at the left. So the order is still the same for matplotlib. For us it looks like it's reversed, but it's still the same. More questions about this plot? Okay, do you know what a violin plot is? Violin plot, as in the violin, the instrument. Okay. So the people that don't know what a violin plot is, do you know what a scatter plot is? Okay, so it's not related. I'm just trying to see what plot is more interesting. So let's do a violin plot because I think they're fun. So one final check. Everyone got this plot? So it's all downhill from now. So if you want to leave, do it now. Okay. So, but we're getting close to the end. Let's just do a couple of violin plots because they're very interesting, and then we will wrap up. So a violin plot is useful when you want to plot a single numerical variable and you want to compare them across, say, categories. So there is in the I keep saying so, I don't know why. In the Pokemon world, there's, I want to say, a prejudice that it's not really the right word, I think, but I think it puts the point across. There's a prejudice that certain primary types are associated with either typically higher or typically lower stats for some cases. For example, it's common, or I think it's a pretty, it's well understood that for the electric type, do you see it there? The electric type is typically faster. For Pokemon people, does this sound like a fair, yeah, so there's this idea that Pokemon of the electric type are typically faster. And now what I want to do is, I want to test this. I want to take a look at I want to create a plot that lets me test or visualize this assumption. Alright, that's the premise of what we are doing. Everyone with me so far? Yeah? Okay. So what I'll do is, I'll copy the boilerplate, and I'll reduce the figure size again so that everything is visible. So now what I'll do is I'll do ax.violin plot. And how does this work? Okay. You give it violin plots, compare. Actually, I'll just plot one and then it's easier to plot one and show you, and then it makes more sense than just talk about it. So let's do Pokemon. Let's do the speed over over the electric Pokemon. So the primary type should be electric. Yes. And now let me do this. Okay, it looks terrible because of the aspect ratio. Okay, but this is a violin plot. So it's missing X label, Y label, and title. But what does this show? Okay, I'll let you type it first. Sorry, I can hear keyboards clacking. So what I did was I accessed the speed, and then I used querying with a Boolean series to get only the electric Pokemon. Notice how I grabbed the type, I compared it to electric with equals equals. This does broadcasting as well. So I'm comparing a whole series with a single string. This does broadcasting. And then I use it to index so that I only access the speed of electric Pokemon. And then this should produce this weird blob. Can you get this thing on the screen? Yeah. So then why can you kind of see why it's called a violin plot if you squint at the blob we got? How do you read this plot? The two bars at the top and the bottom, they represent the minimum and the maximum values that we have. So the maximum value is a 200, so there is at least one Pokemon with a 200 for the speed, And there's, I don't know what this is down here, it's close to 0. And there's one with almost 0. Then this bar in the middle, this is the mean value. So the mean for the speed of electric Pokemon is maybe 90. I don't know, maybe 90. And then the blue shade, the width represents the density. So where the shape is fatter, there's more Pokemon with those values. So what this shows here, because this is the place where it's widest, it shows that there's a bunch of Pokemon, electric Pokemon with speed equals 100. Because it's getting thinner as we go up, it's showing you that there's less and less Pokemon with those values. And for example, over here, this region here, which is more or less the same width in this section, it shows you that Pokemon, electric Pokemon, over those speed values, they're more or less equally distributed inside that section. Okay? So that's more or less how you read a Violin plot. And if electric Pokemon are typically faster, when I put a similar plot but for non-electric Pokemon, then this one should be above the other one. Because on the left, so the y-axis, the vertical axis, is the speed values. I think it will be, the comparison will make more sense if we have the actual plot there. So, do you understand how to read a Violin plot? I think it's a very neat type of plot. So, what we need to do now is stop saying so. And now, in here, in the Violin plot method, what we can do is the first argument that the Violin plot expects can be an iterable of series. Because what's plotted here, this is just a representation of one series. Remember that this is a series. There's no x and y, it's just y values. It's a one-dimensional thing that's being plotted and represented here. And I can give it more, and it will create more violins to compare. So what I'll do is I'll copy this whole thing, and now I'll create a, let's make it a list so it's clearer. So I'll create a list with different series. Now, the first one is for the electric, and the second one is for everything but the electric. So what I did was I changed the equals to a different. Oops, I forgot something. Yes, I forgot the comma. Thank you, Python. And if you change this, now you get two Violin plots. Do you get the two Violin plots? Let me know when you do. So now, how do you read these plots? And how do you check whether electric Pokemon are typically faster or not? Well, you just kinda look at it and try to interpret it. What I was... Yeah, okay. So for example, if you look at the... And this is not very formal, right? This is... I'm just saying some things. The fastest electric Pokemon is faster than the fastest non-electric Pokemon, for example. We can see there, because the top bar is higher up than the bottom bar. We can see that there's a big concentration here of electric Pokemon, and that's wider than this region here on my non-electric Pokemon. I can see that the mean is also higher. And then I can see that for the non-electric ones, there's a high concentration of Pokemon with speeds at these levels, and this one is getting thinner in this region. So it looks like electric Pokemon are faster in general. It looks like this idea that electric Pokemon are faster is kind of reasonable. Okay, this was not a very formal analysis. I'm just taking a look at this Violin plot and reading it with you. All right. So then, what I'll give you as homework, quote unquote, is to figure out how flying Pokemon come into the mix, because there's also this idea that flying Pokemon are fast. So what I want you to do is, there's a Violin plot for electric and one for non-electric. Now I want you to get one for electric, one for flying, and one for everything else, just to make the comparison with these three classes. So that's a nice challenge for you. Now I also realized that I should have given this second half of the tutorial in a different order, because it would be much nicer to end with this plot. It's more of a banger than the Violin plot we just did. So let's pretend we just did this plot. So there you have it. Now, as we have 60 seconds left, I want to tell you what. Marketing is my favorite part of the tutorial, which is not. So the whole tutorial was based off it's actually a shortened up version of a blog article I wrote. And then what I did was, or what I'm doing is, I'm giving a course, a Pandas and matplotlib course at my local university, and I thought, well, I'll just write a short book with all of the contents instead of having everything inside my head. So I'm writing this little book of Pandas and matplotlib, and you can either scan the QR code or type that to get to the book. So that's going to be fun, because I spend way too much time thinking about Python and related subjects and writing about Python. If you get to know me a bit more, you'll see that. And then what I really want you to do, please do this, is scan this QR code, because it's going to take you to a very short Google Forms that has, for you, it has a bunch of relevant links, like the blog article I just mentioned. If you'd like to reread this, the things we've gone through, if you would like a bit more, did I say that English is hard? So the blog article is an extended version of this tutorial. Sorry, that's how you say it. So if you want to redo the tutorial, and if you want to learn a bit more around the topics we've covered, there's a link to that there. And there's also a short feedback form that's very useful, because people typically add lots of excellent suggestions and very good criticism. So feel free to fill that in and let me know what you thought. And I think we can call it a day for now. I appreciate you bearing with me for 3 hours. That's a long time. And I hope to see you around the conference. Cheers.